Good morning, everyone. Welcome to another episode of XA Talk Show. Today is August. Today is September 8th, Sunday, 3 o'clock p.m. San Francisco time. And good morning, Bartholomew. Good morning, Zitron. Good morning, Abdo. And so, what is today's topics? Today's topic is Bartholomew says, explain functional programming with JavaScript. Anything else? Anyone else? Let's see. Ztron. Okay, let's move the window here. Let's prepare. Let's start start command log mod. So you can see all my Emacs commands on the left window, such as cursor right, move cursor right, move cursor up, down, left, forward, backward, and so on. Look at the left window. And okay, so guys, so explain JavaScript, explain functional programming with JavaScript concretely. Would that be a good topic? Everyone? So we are good. We are good to go today. Zitron, hi, hello, Abdo. Abdo, was it you who asked something about explain JavaScript? Let's go to XA Talk Show page. So type guys, type XA Talk Show yesterday. Show yesterday's topic. So yesterday we did explain functional programming, but most of that, so that was 90 minutes, and most of that is rather not with code, but rather about concepts. About I'm just explaining in the air without actual code. And I explained some history, theoretical, how their theoretical computer science background. 90 minutes. And by the way, anyone watching this offline, you can always when you watch your video, make it speed up 1.25 times. Usually that's better for my video. Good morning, WebDog. Have not seen you for months. Because I remember you with the clown face. Uh, so WebDog says, I abandoned Emacs and am a VS Code soy boy now. I heard VS Code is pretty good. A lot of people actually. There's another Emacs guy who also abandoned Emacs and went with VS Code. So maybe I should do that. VS Code. First thing I need to do is to create a softline keys in VS Code, and I think it can be done. Okay, Bartholomew says, good topic. Okay, creepy clown face. WebDog says, functional programming is for people who pretend to be good at math. Not really. Yeah, okay, so in that style, in that style of saying, functional programming is for people who idolize math, but who don't know nothing about math. That is functional programming. Okay, so actually it's pretty good. I do functional programming. I'm a big fan of functional programming. So okay, so let's do explain functional programming with respect to JavaScript. Then maybe let's do that. So let's see text topic. Let's see Abdo. Okay, someone else asked about functional programming with oh, it's a guy from Chile. Uh, and his name is okay. When I'm doing video, I try not to be too verbose and wasting time, but that's a long way to go for me. I forgot who said that. It's a guy from Chile, I'm pretty sure. Uh, Attach Tesh, yes, Attach Tesh says, uh, yeah, about JavaScript. Okay, so let's go on. Let's go on with explaining functional programming with JavaScript. So what are we going to explain? Okay, so let's begin. Let's start to write our topics because that way it's more organized. So explain functional programming in JavaScript. Okay, there is a lot to say about that. And in fact, 90 minutes is barely, we can cover something in that. So first of all, in JavaScript, I have some articles that is about functional programming. So if you go to search for JavaScript in depth with my name, and you'll find functions, JavaScript functions, this section, and there is a page about functional programming in JavaScript. Now, this page is about the very basic, so we can actually start with that. And I'm going also to explain current example of currying in JavaScript and example of clojure in JavaScript. Okay, and yeah, let us get the topics first. So we're gonna cover them. Clojure currying JavaScript does not have list comprehension. Okay, and origin of currying example of functional programming in JavaScript. Okay, iterators. Okay, you have iterators, but that's not functional programming. Okay, so let's just begin then. Let's see where we go and keep the comments coming. Okay, comments and questions. Uh, if there's anything you are not sure what I'm talking about, or if you want, like, and also sometimes I forgot the questions, or I forgot where I was, and if you want me to go, answer that, just type it. Yeah, type it freely. Functional programming in JavaScript. Okay, so okay, JavaScript functional programming. First of all, JavaScript is a language that's uh, JavaScript. JavaScript is based on two languages, Scheme, Lisp, and Self. JavaScript is based on Scheme, Lisp, and a language called Self. Okay, I don't know what is Self, but apparently there are some programming language fanatics who are saying, "Oh, Self is a great, great language." They're trying to tell you to look into all the time, like Julia. Well, like some people, some people want to tell you about Julia. Some people say it's Haskell. Oh, you gotta learn Haskell and like that. I have a friend on Mastodon who is telling me about Self often. Anyway, I don't know Self, but I know Scheme. So anyway, JavaScript is based on Scheme, Lisp, and Self. Scheme Lisp is a functional language of the old times. Like today, like times change. Today when people think about functional languages, they look at Lisp, and Lisp has lots of mutable variables. In fact, you can barely code Lisp without variables, and also function. Rarely function returns a function. That's because Lisp, some Lisp technicalities. So in Lisp, in at least common Lisp and Emacs Lisp, a function usually do not have function that returns a function. But in Scheme Lisp, that happens often. I think. I think. So anyway, JavaScript is based on Scheme Lisp and Self, and from Scheme Lisp is most of the functional features in JavaScript came from. A function can take a function as argument, and it can return a function, and it has lexical scoping. That all these are from Scheme Lisp. And as far as I know, from Self, JavaScript got the so-called prototype inheritance. system from self, which is the OOP prototype based inheritance system is entirely different from Java, Python, Ruby. In Java, Python, Ruby, you define a class, then you create a object. All those classes have inheritance. You have you define a class, then you can extend it. So you got a different class. You can so you eventually you have a tree of classes. They have a structure, hierarchy of classes. Then the class themselves, they do nothing. They are like definitions. They just define the classes, and then you create object out of a class. Those objects are the real thing you work with. So that's Java, Python, and Ruby, and most other, and PHP as well. That's class-based OOP, object-oriented programming languages. But in JavaScript, the OOP is entirely different. Has nothing to do with that, the Java class at all. It's entirely different. That's why it's called prototype-based class system. Good morning, Seamus. So we are going to do a functional programming in JavaScript, explaining that. So let me go back to JavaScript a little bit. So go to my JavaScript in depth, and you can learn about prototype-based OOP. Now this is critical. Like I talked before in my video, you have to understand this well. JavaScript OOP is entirely different from Java OOP or Python Ruby. So if you want to read that, you have to read this object and inheritance, this section, object overview, object type, and stuff. So, but anyway, today we are going to talk about functional programming. Yeah. So that's the origin of JavaScript, based on scheme lisp and self, and that's why it's JavaScript is very functional, but not so good, because JavaScript has tons of tons of quirks, problems. But remember the guy who created JSON, what's his name? Crockford. Crockford. His name. Good morning, Aaron. Python. Aaron says Python professor reporting for duty. Now Aaron is the number one answer. The guy who answers Python questions on Stack Overflow, right? Right. So Aaron is the top Python expert, and here I'm just gonna flame Python all the time. Anyway, so JavaScript is based on scheme lisp and self, okay, and so it's very functional. Now remember the guy who created JSON, who wrote the book, who wrote the book JavaScript the Good Parts. Crockford. What's his name? What's his whatever Crockford, who invented JSON, okay, and he wrote JavaScript the Good Parts. Now this is about 2007. That is what made JavaScript popular, because before that JavaScript is considered hated by hackers. Every hacker hated by everyone. JavaScript and Python and PHP are hated by everyone. So anyway, Crockford created JavaScript the Good Parts, and he is the one responsible for making JavaScript popular. Back then, together with Node.js. Node.js came after his book. He made it popular. In particular, functional programming in JavaScript. He is responsible to kind of make a small revolution in the industry. So then people started to like the good parts, at least the good parts of JavaScript, functional programming. Okay, so good on you, man. It's good to be on top expert. So let's talk about functional programming in JavaScript. So I'm just gonna talk about basics, because Actually, most people don't know the basics. So I have a JavaScript functional programming in JavaScript. Okay, so here's a page. Okay, now I'm going to talk about it without looking at the page much. But after the video, this page will be a good notes. You can after the video, then you read this page. Maybe start to do some code. That will be wonderful. You'll learn tremendously. You have to code to actually let the stuff sink in. So okay, JavaScript in. So what we're gonna talk about? Okay, I'm gonna look at my notes and talk about it. Okay, so let's create a JavaScript. Let's go here. Okay, we're gonna explain currying. We're gonna explain clojure and currying. Those are rather advanced. And let's create a JavaScript page so we can start to write JavaScript. Console log 1 plus 3. Okay, eval the buffer 4. Okay, that's JavaScript. Now let's create a function. Constant arrow function. Now this is in JavaScript 2015. So constant arrow function x. Let's say return x plus 1. Okay, that's a function. Then you call 3. Okay, you call the function with 3 and run it. Result is 4 because 3 plus 1 is 4. Now this is arrow function. This is the syntax of arrow function. On the left hand, you say the argument. On the right hand is the body. Okay, and this arrow function is new in 2015. Now let's talk about arrow function. Well, I'm not going to talk about arrow function, but here's a page about arrow functions, so you can read about it. Arrow function, you see, the basic syntax is like that, but actually it's slightly more complicated. So okay, let me put the link here. It's slightly complicated. For example, another way to write that is, let's see, return x plus 1. So when you want, so if the body is more than one expression, in here the body is just an expression, simple, one unit expression. But if you want it to be more complex, then you have to use the curly bracket. Then you can do, for example, you can say let x equals to let's say let y equals to x plus 1 and return y. Okay, run it. Okay, multiple definition are not allowed. Let's do it again. So you see, that's the answer 4. So when the right side is more complex, then you have to use that syntax. So it's a bit more. The syntax is a bit more complex, and plus you can have destructuring, parameter destructuring and the rest parameters, things like that. So read the page if you are not familiar with arrow functions. So anyway, arrow functions. Let's just use that. Okay, so run it 4, correct? Okay, good. Now a function can take a function as argument, okay, and a function can return a function as argument. Now, first of all, when you code JavaScript, and if you want to do functional programming, then it's a good idea to always use arrow function. Okay, if you like functional programming, then in JavaScript always use arrow function. Okay, now the alternative to arrow function is the old school, like that. I'm gonna show you. Okay, the alternative to arrow function is you say function, then you give it a name, then you say x, then you say return x plus 1. Okay, now comment that out. Okay, now let's run it 4. Okay, so this is a traditional way to define a function, but it's got problems. It's got quite a lot of problems. It's got name hoisting problem. It's got functional expression versus declaration problem. It's got nested function problem. It's got argument object problem. Lots of problems. You can read about those problems in this section. Define a function. In this section, function. So this page explains how do you define functions. So arrow function is good. Then the keyword function is not so good. You got lots of issues. You can read in details. There are so many pages about that. It's hard to explain. It takes 20 minutes to explain because JavaScript is very convoluted. So if you like functional programming, do not use this. And also, let me mention, in industry code, if you work in a company, then everyone is gonna use these. You can't just go your own way and do everything functional because in JavaScript, in the code in the industry, everything is object. You got this, everything so that's the thing. But if but functional programming techniques is also frequently used. So in industry code, you'll see these almost all the time, but you will also see arrow function. So that's what I'm going to explain this part. So remove that. Okay, so let's go back. So yeah, functional programming, to use arrow functions. Okay, that's good for you. Now let's explain. One more thing. So function taking function as argument. Okay, we're gonna explain that. So here's a function. Let's name it f1, and let's create another function, constant arrow function. Let's say f2. Now let's say xf2 equals to what are we doing? We want a function that takes another function as argument. So okay, so let's do this. So this function f2 will take a function. Will take a one argument f. Okay, and it will return whatever f evaluated at 3. So you see what I'm saying? So this function, we just defined the function. It has a variable f, and the return value is f applied to 3. Okay, now we're gonna call it. So let's call it console log, which is for print. We call f2, and we give it a argument, and argument is f1. So f1, you see, we defined here f1 is a function. Let's see what it returns. It returns 4. You see, so this is an example of function taking another function as argument. Okay, so let's delete that, close that, and let's put the code here. So show in browser. There it is. That's an example of function taking an argument as a function. Now let me show you a function returning a function as a function returning a function. Example. Okay, all these are fundamental basic functional programming techniques, so you have to know it. Function taking an argument, function as argument, function returning a function as argument. This is all critical, and in fact in JavaScript it's used every day. Every project, you'll see it used hundreds of times. Every 500 lines, or every 200 lines, you'll see one example of such. Function taking argument as function, and function returning a function. And why is this critical? Because when you talk about more advanced concept like currying, like clojure, and function composition, all those involves these function taking a function as argument, or function returns a function as a result. Okay, they all involve these, so you have to kind of master these basics. So let me show you an example of function returning a function. So let's define a function again, constant arrow function. So we want a function return a function. So okay, so let's say gg. Okay, let's say the function takes one argument. Okay, and it returns a function. Okay, so so let's say return. Okay, return arrow function. Oops, arrow function. Okay, return. You see, we return a function expression right here, and this return function will be a function that takes no argument, and it returns x plus 1, let's say, for example. So do you guys understand what this code is doing? We just defined a function gg. Okay, this function gg, and this gg takes one argument, okay, one parameter, and its body basically just immediately return a function. You see, this is a function, arrow function. It returns a function. This function takes no argument, but the body is x plus 1. So what will happen if we call gg3? Type it, guys. I wait for your answer, okay, before I run it. Let me read the comments. I diversified my approach until I got hired, but then I went deep. Is arrow like a lambda? Yes, arrow function is just like a lambda, exactly. ES6 arrow function are lambdas. Yes, indeed. Nice. I had forgotten. I need to learn JavaScript more. Subpage might teach me. Yeah, check out my tutorial. Thank you, guys. And if you like it, post it. That's how it will become popular on Google, search or other search engines. Okay, WebDog posted this incomprehensible thing. Let's see what that is. By the way, anyone knows the answer? What happens if you call GG? Well, that's probably too basic. I shouldn't. That's too basic. So WebDog says, what is this? Just 5 bind. Okay, this is a what's called interpreted. That's interpreted string. So just 5 bind, a just bind. I don't know what that is. What is just? Oh, implementation of just left us an exercise to the reader. Okay, so anyway, that's probably something advanced. I'm not going to cover it. I'm not gonna talk about it. Let's continue. We gotta finish. Oh, it's a monad. Oh, okay, that's interesting. I'll check it out later. Okay, we gotta finish a lot of things here. So this will return 4. Obviously, let's run it. Oh, it returns a function. Oh, wait, wait. So you see, right? GG returns a function, obviously, but the thing is, since GG is a function, you have to call it. Give it a argument and have it evaluate. So let's do it. So that's how you do it. So if I run it, you see the answer is 4. You see. Okay, let me repeat this. Okay, so GG is a function. Okay, example of a function that returns a function. Okay, GG is a function. It takes one argument and it returns this function, and this function basically just add 1 to the argument. So now we call GG. When you call GG3, it actually return a function. For example, we can show type of. Okay, you see it says a function. The type is a type of function. For example, let's do this equals to run it. You see it says true. So what GG returns is a function. Now we have to call that. So that is why we have this line. We have it this line. Okay, let me show you this. So this returns 4. Okay, so you see all return true. So this is an example of function returning a function. Okay, let's put it here, color it, show in browser. Okay. Now function taking an argument and function returning an argument, all critical things. Now what are the other things we want to talk about? Let's see. Arrow function. Okay, you learned arrow function. Apply a function to a value. That's simple. You just put a parenthesis after it. That's how you call a function. Yeah, let's show this. Let's show this. Because usually when you type in real time, people get it more deeply than otherwise. So console log, create a arrow function x x plus 1, and so that is a function. Now we want to apply that function to 3. Then you just put a parenthesis 3. Okay, then it returns 4. Okay, that's a general way to apply a function. Meaning you call the function with the argument. Just like the traditional f3. That just like that. So this is applying a function by putting a paren to the right of it. Applying a function that is call. Okay, so that's that. Put it here. Okay, that's how you call a function. Now let's see. Function type is a function. We don't care about that. Assign a function to a variable. That's also critical. Okay, all these are fundamental. So let's do that. Oh, actually, we showed many examples of that here already, because arrow function is a function expression. It's a lambda. It's an expression. So you can actually assign it to a variable, because function is a value. Just like any value, you assign a variable. So you can see here. Let me go over a tangent a little bit. You see, functional programming in a sense is very simple. It's you just have concepts, very small concept, and you combine all those concepts to create programs. So here we see that we have the concept of a function. Then you have the concept of assigning something to a variable. And obviously then you can combine them. So you are assigning a value to a variable name. And this variable name, now it becomes a function. So this, in a sense, this is actually a simpler idea, in programming, as opposed to, you have function declaration, definition declaration, like define or something like that, or then you call it. But so once you have lambda, it's simpler in that sense. You just compose concepts. So okay, so that's about assigning a function to variable. Okay, then function returning a function, we showed a example of that. Function taking a function as argument, we showed an example of that. And function composition. Okay, now here is starting to become advanced. Now in order to do this, you have to be thoroughly familiar with, be comfortable with the function and returning a function, or taking function as argument. So this function composition is the the most fundamental, after what we just explained. Function composition, it's used in math everywhere. So you have function composition, then you have closure, you have currying, you have Y Combinator. Now the Y Combinator is the most complex and theoretical. It's actually useless. It's 100% useless in actual programming. But that's how the Y Combinator, the startup, the Paul Graham website is named after. Y Combinator. So by the way, I did a video about the new kind of science, where I explained some of these things. Y Combinator, that is a good one for those of you guys who are interested in this computer science related subjects, a new kind of science, cellular automata, lambda calculus, Turing machines, Y Combinator. So that is last week or 5 days ago. Just search for a new kind of science. Where is it? Unix pestilence, science tech growth, plane curves, keyboard, Unix pestilence, language eccentricity, scientific programming. Here, math languages, scientific programming, new kind of science. This is August 28th. Okay, so that's good to check out. So okay, so okay, 35 minutes. So let's explain function composition. Okay, let's create a new JavaScript. That's function composition example of. Okay, so we want function composition. So what we want to do. So first of all, what we want to do. What is the goal of function composition? Function composition is you have a function, constant arrow function. So let's say f. Okay, let's say this. Okay, let's stick with x plus 1. Okay, so here's a function. It just add 1. Okay, let's create another function. Let's say it minus 1. So when you have functions like you want to call, okay, let's call them. Call f. Okay, so let's call f3. Okay, now you want to okay, here's the thing. You see, you are calling f3 now, and after that you got a result. You want to feed that result to g and get a new result. Let's see what we get. We got 3. It's like doesn't do nothing because 3 plus 1 is 4. 4 minus 1 is 3. So it returns 3. Now, when you call a function, take its output and feed it to another function. That's very common because remember in functional programming, that's all you have. Functional programming is made of 2 parts: function definition, then function call. That should be the whole entirety of your program. Define functions, call them. That should be it. Okay, no object, no inheritance, no nothing. Define functions and call them. So when you do functional programming like that, one pattern that comes up all the time is sequencing of functions like these. Because once you call a function, you got a value. What do you do with that value? Of course, you want it to feed it to another function. That's functional programming. That's so these patterns happens all the time. So now there's a new idea. What if you can create a new function? Let's say fg. Let's say edge. That is the combination of f and g. Like this example. Function chain. In a sense, you call it function chain. So you can define it like this. Okay. So let's do that. So constant arrow function. We're gonna define edge. And h is gonna take 2 arguments. Let's say xy. Okay, takes 2 arguments, and what we want to do is actually so simple. Let's just write it here. So let's just write it is like this. Okay. Yep, that's it. Okay, that's it. I think that work. So you see, h is a function that takes 2 arguments. Now these 2 arguments are both supposed to be functions, and what it returns one function feed into taking the output of one function feed it into another. Actually, this is not right. We need an argument here. Let's say let's cheat a little bit. Let's just say let's put n here. Okay, let's just make this work. So any questions, any comments? Let me finish this. Keep the questions coming. Okay, is so far so good? So let's run this. Okay, so let's run this and see what happens. So we are going to call we are going to call console log. Okay, h and give it f and g and give it 3. Okay, run it. It returns 3 as expected. Okay, so this is an example of function composition, but actually it's not pure because we got the n here. Originally, what we wanted is a function that is a function that takes two other functions and returns a new function. This new function will be equivalent to calling the two functions combined. Okay, we can do that. So let's try it again. So f takes two arguments, both of them supposed to be functions, and it needs to return a function. So I have to think about it. Okay, so let me think about it. So y is x and y are functions. h2 needs to return a function. So y is a function. Okay, so there's a way I can do it, but so any questions so far? Like any, let's okay, so let's get back to this. So let me work this out then. So h2 is a function that takes two functions. Okay, give me a minute. Okay, takes two functions and returns a function. So it needs to return a function, and this new function is x and y combined. So y is a function. So this function we needs to. So one way to do it is like this. Okay. So one way to do it is create a arrow function. So arrow function, let's say let's change the name because it's more clear this way, more intuitive. So takes two functions f and g and returns a function, and this function will be that'll work. This function will be f and g combined. Okay, that should work. So you see we got a nested function situation here. So you see h2 is a function, and here is its definition. It's an arrow function, and it takes two arguments. Both are supposed to be functions, and here is the body of h2, and the body is actually another function. So we got a nested function happening here. You see, this is another feature of functional programming language. You should be able to define nested functions. So it returns, a new function. This new function takes one argument, and yeah, that should work. Okay, so let's do it. So what we're gonna do here is call console log. Actually, let's just copy this console log fg. Okay. First of all, let's say, yeah, let's just run it. Nan is not a number. This is incorrect. Oh yeah. Wait. We should say h2. Okay. Now let's try it again. Correct. You see, it returns a function. h2 here returns a function. Let me do this. Okay. Type of that equals to function. Okay, run it. It's true. Let's do this. Equals to 3. Okay, it's all returned true. Now f2 is correct. It takes two functions and it returns a function. So far so good. Now we want to see. Actually, let's put this down. It's a matter of trivial style. I fuss about them all the time. Sometimes I feel this is a better way, and other times I feel the all comments should be below the function. So I do that all the time on my tutorials. So anyway, so f2 is a function. Now what we do is we give it a value. I mean, we apply it. Remember how to apply a function? You just put a parenthesis and you put 3, and the result should equals to 3. Let's run it. True. Great. So this is a success. So actually, so let's take out h here. Let's just replace that. Take out h. We don't need h here. Yep. Okay, let's put it here. Show in browser. So that's a function example of function composition. So no comments. So far so good. Comments, guys. Comment. Okay, so now let's move on to great. Okay, great. Thank you, Abdul. Okay. Hi, Spinal Camp. So we finished this page about the most basics of functional programming. Now we can explain. We can go on and explain clojure and currying. Okay, we can go on and explain currying. Let's do currying. So why not use Markdown? I don't use Markdown. I don't use I don't use Markdown. I don't use orgmod. Because I've been hand manually writing HTML since 1996, so I am so used to it. And with the help of Emacs and my own commands, so it works perfectly for me. I don't use the Markdown, and so I use HTML. Like 10 years ago, there's tremendous controversy, like HTML versus Markdown. And by the way, before Markdown becomes the universal standard, there are many different so-called light markup systems. I don't remember the names even. But if you go to Wikipedia, you go to Markdown page, you can start to see all the others. Okay, it's kind of gone now because now everyone is like Markdown or OgMod if you are an Emacs fan. But back then, there are all these, and it's controversial. And like hackers talk about it all the time. You know, yeah, Pandoc is one of them. They talk about it. There are so many different variations of light markup, and even today, you have, for example, let me show you. Okay, I started to digress, but I'll get back right away. So if you see, for example, Xar code, go to programming, actually go to hacker code, then you go to the bottom, you see search for markdown. Wait, what? Mark. Um, History, death, persons, new software tech. Okay, new software tech, uh, stuff, and lots of stuff. Ah, I don't know. So let's just Xari markdown. I'm gonna get back to the functional programming just in a second. This is gonna be just 1 minute. So Markdown, I have a tutorial here. Then you will see Hammer, SAS, YAML, Slim, all this crap. They are all markup languages. They all try to do some. They think they are good, very popular even today. They come and go. Some becomes very popular, then not so much. So Hammer is one of them. Hammer is for kind of translates to HTML. Uh, yes, a template for HTML. Then you have SAS for CSS. SAS has two versions because things change. They have two versions. One is based on Python syntax. So maybe you like it, Aaron. So is SAS is for CSS. Okay, it's an alternative syntax for CSS, but it has two versions over the years. Now they have two versions. One is based on like Python, indentation. Then the other one is based on like CSS, with brackets. Then you have YAML. YAML is another one based on Python syntax. I don't like the indentation syntax. I have a lot to say about that. I have an article about that. Then you have Slim. Slim is another indentation based syntax for HTML. Okay, so that's about that. And also all these are kind of some of these are actually pretty old. There's also mustache. Like I think if you are in Ruby community, you have a bunch of more. And very popular too. But even before all these, there are quite a lot other light markup. For example, there's a BBS. When PHP is ruling the world, everything is PHP. You have the what I think it's called BB bulletin board markup. That's based on PHP syntax. Yeah. Okay. So there are so many. I'm just used to HTML. I stick to a simple version of HTML, and I don't use OgMod much. Okay, let's get back to JavaScript. Let's start with the currying. Okay, currying in JavaScript. Okay, so what is currying? Okay, so first of all, currying is decomposing function that has multiple parameters into a sequence of functions, each with only one parameter. Okay, that is the concept of currying. And in programming languages such as Haskell and OCaml, ML, standard ML, F sharp, they all have currying built in. That is, whenever you define a function that involves more than one argument, it automatically decomposes them into a sequence of functions. Each one only have one argument. So when you call all these functions, like chain them together, it's equivalent to the original function with multiple arguments. That's what currying is. So in fact, in languages like Haskell and OCaml, they technically they don't allow you to define a function of more than one parameter, because at heart, at the core of the language, you only have function with one argument. And why is that? Why is that good? Because of theoretical computer science. Okay, we are not going to get into about that. But let's show an example of currying in JavaScript. Now, of course, JavaScript do not support automatic currying. You have to do it manually. So let's show an example. So constant arrow function. Let's define an arrow function again. Let's say two argument, and let's say we return x plus y. Okay. Now that's a function with two arguments. Let's say 3 and 4, and return 7. Return 7 true. Okay. And now we want to curry. That is, we want to write two functions, f1 and f2, such that when they are each one has only one argument, and such that when they are called in sequence, they are 100% equivalent to this ff. So let's do that. Okay, constant arrow function f1. Okay, so how do we do that? It's very easy. Okay, so but when you actually do it, you have to think. You have to think a little bit. Yeah, handlebar is another example of the markup language template that converts to HTML. Handlebars. Uh, a very accomplished programmer, but he's a creature of his time. Okay. Yeah, there are so many of these light markup languages. Okay, so let's get back to this. So we want to write two functions, f1 and f2, such that when called in sequence, they are equivalent to ff. So let's make f2. F2 should return a function. Okay, so this needs to, you have to think about it. Which is, this is how you learn functional programming. When you really want to understand currying, and if you are using Haskell or Camel, you read about currying, but it's all automatic. You don't really get it. You kind of get it, but you don't, because it's automatic. But when you actually use a language such as JavaScript that does not do it automatically, you try to code it yourself. That's when you actually really the concept sinks in. You realize what you will run into many errors, like syntax errors, semantic errors, but once you get it, once you eventually you'll get it, then you learn a lot that way. So right now I'm like stuck. So I have to think about how you do this. So two functions. So f2. So what we want, first of all, let's show you what we want to do. So the result should be, this is what we expect. Okay. So f2, we call f2, give it argument, then we call f1, then y, and it will equals to this is the result. This is the desired result we want. So fxy, so instead we have f2, we call f2x, then result feed it to f1. Yes, and f1 takes a argument of y that should equals to that. Okay, so first of all, this is kind of the spec. So f2, so now we know what f2 should do. So f2 take an argument and returns a function. It returns a, yes, it should return a function. Wait, yes. So f2 should return a function. F2 takes an argument and return a function. Okay, arrow function. The function will like that. Okay, y plus 1, something like that. So f2 takes a value, takes a value of x, and it returns a function. This function will take a value and plus x, right? Plus x. That's right. So here, so that's right. So that's f2. Now, when you give f2, now this result, which is a function, will need to go into the input of x1. Okay, so here the we'll need to go into the input of f1. So f1 will take a variable, which is a function f, and it will return actually. Yeah. So f1 will take f1 will take a function. Oh yeah, so f1 will take a function, and f1 will also return a function. That's right, arrow function. Because you can see here, you see the result of f1 should be a function because we are going to feed it y there. So f1 will return a function. What this function will be? Oh, that easy. Okay, so it will be like this. So it will call f. It will call f with the input of it will return a function. Yeah, I'm getting silly. This is probably if I rehearsed it will work. Oh, this is that right? So after give a answer right away equals to, is that right? Maybe you are right, but I have to think about that. Well, if I, it's like there are two branches of thinking. If I focus each one, let me just continue my own thinking here. Uh, so okay, so let's just try this, see if that works. Let's see. F1 equals to y is a function. No, I don't think that work. This f1 equals to y is the argument. Y. Okay, so let's run it. Let's see what happens. So here, um, let x equals to 3. Okay. Let y equals to 4. Okay. Let's just run it. Let's see what happens. Yeah, I don't think that's, there's some syntax error we need to fix. Yeah, that after some fix it'll work, but it's similar to that. So f1 needs to f1 takes a function. Let's see. F1 takes a function, and f1 should return a function that takes one argument. So return a function that takes one argument. Maybe that. Okay. Maybe that. Oh, it worked. Okay, Moonbase also give the answer. I don't. Well, let me just get on with the way I have it here. Okay, so now it's successful. So this ff is a function that takes two args. And now we define two functions, f1 and f2. Okay, such that um, such that this is true. When we call f2 with one argument, then we feed it to f1, then we give it another argument, then it will equals to ffxy. So this is true. So let's change any value, it's true. So that's so great. So success. That's an example of currying. Meaning decomposition of function with multiple arguments into a sequence of functions. Each one takes only one argument. You see, this function only have one argument. This function only have one argument. So that's currying. Cut it, paste it here, syntax color it, and we have today's notes. All these we covered today. I have them. I have written tutorials here in detail. How long have I been talking? So 1 hour and 7 minutes. So you guys can actually read it here. And also about currying. Let's go to my. I think I have a tutorial. Let's see. Let's go to programming jargons and go to currying. Yeah. So I have an example in Mathematica, in Emacs Lisp, in Perl, in JavaScript. So I have those examples. Okay, so we covered, actually, I think this is pretty good. I think it's pretty good. These things, again, currying is not actually practical. So in JavaScript, actually, you don't use it. You almost never use it, even in industrial coding. Even if you like functional programming very much, that's something you don't use, because currying is for decomposing function into function with just one argument. Why you want to do that? It's only because theoretical computer science advantages, and like in Haskell, they want in Haskell case, in the case of Haskell or meta language, or Camel F#, they do that because they are strictly typed language. So it would be simpler. So every function is just one argument. Every function is only one argument. That's simpler because one argument, each argument has types. So you can So you reason. So whenever you have a function with three arguments, let's say it's common. If you want to plot a function, a surface, or math functions, a function has many arguments. You can rewrite them so they become functions, each with only one argument. You just chain them together. So and from a logic point of view, it's much easier to reason. You have what type it is, it becomes what type. You have. That's why Haskell and Ocamo, they have that. But in practice, that's only for theoretical advantages. In practice, you don't do that manually. There are like occasional reasons to do that, but let's not get into that. Typically you uh, you just don't do that. So that's about currying. But the composition and other things, function returning a function, nested function, and function taking an argument, that's all critical. And in fact, you have seen, actually, we used all of those things when we want to do composition and when we want to do currying. We have nested function, we have function return function, and function taking an argument as function. That all happened. That's very practical. Then there's another thing about clojure. I don't know if I should go into that. Clojure, again, in my opinion, it's no good. You shouldn't do that. Let me put this link here. Clojure. So anything else, guys? So should we go over clojure, or what else? Like 1 hour and 10 minutes, so 70 minutes now. Anything else? Moon-based snails, handlebars. So what else? So which type of Emacs for Mac do you use? I use the one from you mean what distribution? Let's go to my Emacs blog, Practical Emacs, where to download. And on this page, I tell you where to download. You have Windows versions, precompiled Windows versions, Mac versions, and Linux. The one I use is this one, Mac Emacs for Mac OS X. I just use that one. They have a new version right now. It's 26.3 that just came out last week, I think. And right now my version is 26.2. Yeah, so I need to upgrade. Okay, let's cover the clojure then, just for wait. Okay, so let me think. What's important about functional programming? Emacs blog, close it. Talk show. Okay, so functional programming in JavaScript. What else are important? Arrow functions. Yes, arrow functions. Clojure. So okay, so let's go to clojure. Clojure. So go to programming jargons. Go to clojure. Here is a page that explains clojure. Oh, I already showed it. Okay, so it's already linked here. So you have clojure in JavaScript. You have clojure in Python 3. Python 2 does not have clojure. You cannot do it. You have to do it in Python 3. And then you have clojure in Golang. So what is clojure? Clojure is actually comments, guys. Comment. maybe closure. I explained yesterday. So okay. So let me finish then. So let me explain closure. Then that'll be it for today. So closure, there are a lot confusions and misinformations on closure, and closure is one of the things that programmer hackers types. They chant it all the time, just like the other jargons we talked about yesterday. Closure, macros, monad, tail recursion, currying. They blow. You hear these out of proportions every day on social networks, on Hacker News, on Reddit. It's like, and also like a Turing machine, Turing completeness. Is crap, all crap, because those are fairly advanced concepts. You have to really know the basics very well to actually appreciate them. And most of them, all these jargons mentioned so far, they are many of them are not practical. Okay, they are not practical things. But anyway, closure. Okay, so let's talk about closure. Closure. So what is closure? Closure is a programming feature. Okay, so there are many explanations, many different definitions. One of the most critical definition, I would say the most um, correct perspective of closure is that closure is a programming language feature. Okay, this is important. Closure is not some particular function. Closure is not some particular programming technique. Although in some perspective you can say it's a programming technique or idiom. Okay, you could say that. And closure is not um, okay, so most importantly, closure is actually a programming language feature. Okay, and what is this feature? It is a feature that results from. Well, I talked about this yesterday. For 10 minutes. So let me okay, let me finish. Like indecisions. Like, yeah. Okay, so closure is a programming language feature. How does this feature came from? It came from three things. One is lexical scoping. Okay, one is nested definition of functions. Nested functions. We showed some examples of nested functions. So lexical scoping, nested functions, and functions that returns a function. These three things. Okay, lexical scope, nested functions definition, and function that returns a function. When you have all these three features in a programming language, then something strange happens. That is, when you have a function that has a nested function, and when this function returns this nested function, what happens to the function, to the return function, when that function actually calls a variable, uses a variable that is not in the nested function? Okay, this may appear complicated. It is actually. That's why there's a lot misunderstanding. But we're gonna explain it. Okay, we're gonna explain it with code. So remember, next lexical scoping. Okay, first of all, you need to have lexical scoping. Then you need to have a nested function. Then you need the function to return a function. That is basically return this nested function as a value of this function. And also, this when this nested function actually use a variable that's not local to it, it actually uses a variable that is part of the outer function. Okay, when all this happens, and so when all this happens, when you call this function, it returns a function. Returns this function. There's a curious question. What will happen to the value of the variable? You see, because there seems to be a paradox. Because on one hand, this variable of the result function is not local to the nested function. It's not local. It's the variable is actually defined in the outer function. But however, the outer function is kind of a gun because the outer function finished. It returned the nested function. So on one hand, this variable is already gone. The value is null or nil. In whatever language, in null, nil, whatever is gone. But on the other hand, you have lexical scoping. So lexical scoping is supposed to capture the variable. Okay, remember this is the context. This is the context and the origin of the concept of closure. And this happens in the context of designing programming language. That is, you are designing, you are creating a programming language, and you run into this problem because when you are a functional programmer, you are creating your own greatest language. You want lexical scoping, yes. You want to be able to have a function with nested definition, nested function, yes. You want that because that's nice. Because sometimes a function, you want inner functions that's only used by this function. So that feature is nice. You want to have that. But you also want to be able to have a function that returns a function. You see, you want all that. But now you got a problem. What happens when user return a function that's nested, but it actually use a variable that's not local? You got this problem. So that is the origin of closure. So what is the choice of closure? Closure basically, the return function will maintain the variable value, will be there, will still exist, even the outer function is gone. So does that make sense? That is the origin of closure. Okay. So let me. We are going to go into code in a moment. So remember, closure is, first of all, it is a programming language feature. Okay. It is a feature, meaning that some programming language will not have it. Like if you do, like what we said, it'll behave, badly. It'll not have the behavior you expect. So first of all, remember this is a programming language feature. Then, after you understand that, then in a programming language such as JavaScript, it supports closure. When you code that and you return, you have a function that returns a nested function. You could call that closure. So you can say, oh, this function is a closure. So in this aspect, in this perspective, you can say closure is a technique of functional programming. It's kind of a technique or a specific function. You can call it a closure. But remember, these are just different aspects. Originally, what it really is a feature, is a particular feature of programming language. And it's about a function that returns a function with a lexical environment. Okay, so let's show some example of JavaScript that is a closure. Okay, so I hope did I do well on that? I hope I did. It's slightly complex because when you get into advanced functional programming, this happens a lot. This kind of convoluted thing happens a lot. And one of the greatest example of this happening is Y Combinator. You can try. Try to go to Wikipedia. Try to read about Y Combinator. It is very hard to understand. Because you have function that returns a function that takes a value somewhere that it's very hard to understand. So closure is kind of a similar thing, but it's not too hard once you learn, persist and learn it. So let's create a function. Let's create a closure in JavaScript. Okay. First of all, create a function. Let's use arrow function. Let's always use arrow function. So f constant arrow function, ff is a function that takes no argument. Let's say let's actually it's easier just to copy what I have here because that's save time. It's save time. Let's just copy it. So prepare to create a closure. So here we have a function named gg. So here's the function body, and inside the function we declare a local variable x, and then we declare another function, nested function. You see, ff is a function, and this function uses the local variable x, the variable outside of the function. It uses that, and it just returns let's not use that. Let's just say x plus 1. X plus 1. Okay, it just returns x plus 1. I mean, it just increment x. Okay, it increment x. So ff is a inner function. Then this function simply returns the ff. Okay, now when you call gg is this function. Okay, now you call it, and what is the value? Its value is a function. Remember, because it returns a function. So now it returns a function, and you assign that function to cc. Okay, now cc is a function. Now if you call cc, what happens? Let's analyze. Okay, when you call cc, what is the value of cc? The value of cc is the value of calling gg. And what is the value of gg? Well, the value of gg is f, basically this inner function. Okay, so when you call cc, it is actually like calling ff here. It's calling this function. And what happens if you call that function? Let's try to see what happens. So when you call ff, it increments x by 1. So x is originally 0. So now the result is 1. You see, then when you call cc again, it increments x again, it becomes 2. And when you call it again, it becomes 3. Okay, so let's run it. Okay, so you see it's all true. So this works out, you see. So that's closure. Okay, now remember, this is no longer functional programming. You see this cc, because remember, functional programming is about function without side effects, meaning that every function, its output entirely depends on the input, the arguments. Now this cc is not like that, because each time the argument is no argument, but now the output is different every time you call it. So this is cc is not a function. It's not a pure function. It's not a function. It is actually a function with side effect, which is not a function at all in a strict sense. So it's very bad. It's anti-functional programming. So that's why I say never use closure. Some people, they say, oh, I love closure. That's all crap. The moment you use closure, it ceases to become functional programming. You are in fact, doing anti-functional programming. Okay, and also let me mention, closure is the origin of object-oriented programming. Okay, remember, first of all, you need lexical scoping. Then you need function with nested function definition, like that. We should allow, the programming language must allow nested definition of functions, okay, as a feature. Then you need the ability for function to return a function. You need these 3. Then what happens when you do a function that returns a function that uses a variable that's in the outer function? That's closure. When this happens, you have a closure situation. Okay, this closure is the origin of object-oriented programming. In fact, what you have here, cc, this cc is now a class, like Java, Ruby, Python. Okay, what you have is actually now a class. Okay, and this x is the data, is the what they call, you know, um, uh, static variable, or either class variable or instance variable, depends. Okay, so anyway, so what I'm saying, so here, you can see that closure is the origin of object oriented programming. In fact, this GG is actually a class, and this CC is actually a object. When you call it, when you do this, CC equals to GG, this is called instantiation. Okay, this is called creating an object. So it's idiocy from this point on. From this point on, so that is why I say don't. The closure is no good. Closure is the antithesis of functional programming. And that should conclude, on that note, that concludes today's talk show on functional programming in JavaScript, concrete explanation of functional programming with JavaScript. Okay, so let me read the comment, and that'll be it. So if you have comments, type it now, and we're gonna shut down in 1 minute. So Aaron Ho says closure when inner function closes over a variable in an outer function scope, and can later use those variables even when not in outer function scope. Yes. Yeah. So you are doing great, because I just started watching and I thought you said closure was a programming feature and was very confused. Yeah, closure, the closure language, that Lisp language closure, they borrowed the term closure. I suppose, I don't like it. The rich hickey, I suppose, why would he do that? Because because you see a paradox here. Because on one hand, Rich Hickey, he is very much into functional programming. He loves functional programming. In fact, he want to closure is, his language is most about immutability, functional data structures. No no change of value. So anyway, he loved functional programming. But however, he named his language closure. It's kind of like a pun to the closure concept. It's a pun. So that's very annoying to me. Why the fuck you do that? Don't do that. And in closure the language, closure Lisp the language. I suppose I'm not sure they actually encourage the closure thing. I don't know if they do that or not. But the name is just annoying. So Bartholomew says, what's really common and useful real-world example for closures and returning? Don't spell it wrong. Remember closure with S, not J. Okay, closure is not CLOJURE. Okay, closure is not J. Okay, let's emphasize. Okay. Oops. So Bartholomew says, what's really common and useful real world example of closure and returning function? Okay, remember those are two different things. This is important, Bartholomew. So when you have a function that returns a function, this is critical, this is fundamental, and this is useful. This is used all over the place every day in every project. Function that returns a function. Okay. Now don't confuse it with closure. Closure is when you have a function that returns a nested function, and it also uses a outer functions variable. Okay, so it's kind of complicated. And it's so when you have that is closure. Okay. Now, if you want to do functional programming, you don't use that. Some people do. Okay. It's like depends on your opinion. Okay, but this is very different from just function returning function. Function that returns a function. This is useful, used everywhere. But function returning a function such that that function uses some other variable outer function, that's no good. That's not functional programming. Okay, people do use that for people do use. So why is clojure useful? Clojure is useful because you use that to implement object-oriented programming. That is a major use. Every object-oriented functional like Java, Python, they all actually basically they are doing clojure. All of them they are doing clojure. Okay, so that is why clojure is useful, but that's not functional programming. Okay. Um, Yeah, so in other words, clojure is just a function that maintains state. And in function that's what you do not want to do in functional programming. Functional programming, a function, you don't want to have a state. Never. Uh, yeah, okay, damn marketing. Yeah, yeah, yeah. So remember Bartholomew. Remember it's very different. Okay, clojure and functional returning function. When you have a clojure, you use all these features. You use the feature of lexical scoping, you use the feature of nested functions, you use the feature of function that returns a function. All these three, when you use them together in certain way, you have this kind of thing called clojure. Okay, that's that. Don't confuse don't confuse it with all the different features of functional programming. Uh, Yes, well, Thomas, if watch, I explained this enough times. I think with many repetitions. Yes, every Java class is kind of so. Clojure is an origin of object-oriented programming in the style of Java because when you have a clojure, that's a class. I explained that. So that's about that. Okay, so Bartholomew says, show me one of the most common and useful example for function returning a function. We just showed many examples. We just showed, for example, in Java, in Bartholomew, for example, in functional programming JavaScript, we showed composition, right? When we showed composition, we need to have a function that returns a function. So that's an example. And when we showed clojure, that also happened. We need function that returns a function. There are a lot used. In JavaScript. Okay, so you are asking what's a common use. Besides this, there are a lot use of function return a function. It's all over the place. For example, in JavaScript, in industrial code, you have things like no, especially in callback functions. In typically they call it callback functions. Function taking an argument that functions taking another function as argument. In JavaScript, among the industrial coders, they call that callback function. Why is it useful? Because especially it's used in Node.js, because then you have promises. Once you code JavaScript, you'll know. Like once you get into, you start to code a lot of JavaScript, you'll see it's everywhere. It's everywhere. Uh, yeah, real world example. Okay, so real world example. Well, okay. Well, the easiest real world example. Let's go to one of my packages. Then we'll see it. Let's see. Uh, Yeah, so yeah, good question. So let's go to let's go to Xadro. Okay, so this is my um, okay, showing Chrome. So this is my package that does plot with JavaScript, DOM, and SVG. I talked about this a few times. For example, this code this code is this page, and this is the code, and it needs two JavaScript code, and the code is just okay. Here's the library, and this is the code. You just say parametric plot, two parametric plot that just generate these sign plots. But the library, this is the library, and it uses TypeScript. TypeScript, and it's 500 lines. So we need to check, do I have a function that returns a function? I'm not sure I do, but let's search. Okay. So all these are function definitions. We want to see a function that returns a function. I don't think I have it here, but you will, it's like, okay, for each, wait, yeah, for each, okay, it's here it's used in for each all the time. Basically every time you use map and for each, yeah, that's a that actually answers the question. You know about the map, right? Let's show an example. Okay, let's go back to my talk page, go to today's talk, uh, uh, and the most common example of function taking a function is in map and for each. Whenever you call that, that actually it's a function that takes a function, because map is a function, for each is a function, and their argument is a function. Okay, so this is this is absolutely, this is probably the most used example of a function that takes a function. Well, but what about a function that returns a function? Yeah, okay, so there's another example. Let me show you a function that returns a function. Okay, first of all, let me show a function that takes an argument. Let me show an example of map and for each. Okay, so anyway, so WebDog has some answers probably. Real world example. Okay, so real world example. Let's say let's demo a map. Okay, so constant. So let's say AA is an array. Let's say 1, 2, 3, 4. Okay, I want to add 1 to all of them. So AA dot for map. Okay, then map takes two arguments. The first argument is a function. The second argument, don't worry about it. Yeah, because Java has lots of words. It'll take 10 minutes to explain. So so we need a function here, arrow function. So x, here we just say x plus 1, x plus 1 again. Okay, so that returns that does it. So we just need to, okay, so constant result equals to that. Okay, so let's not say, let's say okay, so that works. So it returns 2, 3, 4, 5. It applies this function to every value of the array. You do this all the time when you use DOM. Okay, so you do this all the time when you use DOM. I could show you an example, but it is common. You have to, it's common when we actually do DOM. It's very common every day. It happens every day. Then, okay, so this is an example of function that takes a function. Okay, so just to be sure, let's write it out. Everyday example. Okay, so that's everyday example. What about everyday example of function that returns a function? Okay, that's also very common. For example, in JavaScript, you have, let's go to the function, call apply bind. Okay, so uh, bind bind is the one. So bind is a function that returns a function. Okay, why do you need it? Well, we have to explain the value of this. Then it'll take 10 minutes. Okay, let's not do that. But bind is one of the function you use often. Not that often, but you use often. It is, it's part of JavaScript. So in JavaScript you have a function bind that returns a function. And in a lot of places, in promise also, in other places, you'll know it when you started to code actually, to code real life JavaScript. Okay, that's it for today. So thank you guys for watching. And yeah, closure and partial. Okay, so you like closures and partial functions for callbacks. Okay. Yeah, okay, so that's it for today. So hope to see you guys next time. And for you guys and all the people watching, if you like my stuff, buy my JavaScript tutorial, PayPal and Patreon. Yeah, okay, so support me. So bye guys.